In this video, we're going to factor a couple of polynomial expressions using the technique of factoring by grouping. One of the important things to note with factoring by grouping, which is what's listed here, is that this is used for four-term polynomials. And what we'll do is we'll group this four-term polynomial into two groups of two. And then we'll apply this process. So let's get started with our first one. We have x cubed plus 6x squared plus 4x plus 24. So the first thing that we want to do when we use factoring by grouping is to group this into two pairs of two. So I'm going to group x cubed plus 6x squared with parentheses. And then I'm still adding, of course, so I'm going to now group the second two, and I'll add 4x plus 24, and that's grouped with parentheses. The process by which I can just group these is the associative property of addition. So I've grouped them into two pairs of two. Now, my objective in doing this is that I'm now going to see if these two pairs of two have a common factor. And when this method can be applied, each of those two groups of two should have a common factor. It's going to be a binomial in general. Well, let's see what happens. So I have this x cubed plus 6x squared. That's my first group. And I'm going to factor out the greatest common factor from that first group. So looking at that first group, x cubed plus 6x squared, the greatest common factor of those two terms is just x squared. So I'm going to factor out x squared from that first group. And when I do that, I'm left with x plus 6 in parentheses. So that's my first group. I'm still adding my second group, and I'm also going to factor the greatest common factor from this second group. When I look at 4x plus 24, the greatest common factor between those two terms that I can factor out is a 4. So I'll factor out a 4, and what I'm left with is then x plus 6. And now this is the key point with factoring by grouping. I have x squared times the factor x plus 6, and then I'm adding 4 times the factor x plus 6. So of these two groups, x plus 6 is a common factor to each of them. So now I can factor out x plus 6, and I'm left with, so when I factor it out of that first group, I'm left with an x squared. And when I factor it out of that second group, I'm just left with a positive 4. So now this factors into the expression x plus 6 times the expression x squared plus 4. And now that four-term polynomial is fully factored. In later factoring, you may find that what remains can be factored further. Here, this expression is fully factored. All right, for our second example, we have 6xy plus 15x minus 14y minus 35. Again, a four-term polynomial. And in using factoring by grouping, we're going to group this into two groups of two. In general, it's easiest if we're adding these two groups of two. So when I group it, I'm going to group these first two. So I have 6xy plus 15x, and I'm going to group that with parentheses. Now, because I'm using the associative property of addition, which doesn't work in the same way for subtraction, I'm going to group it, put addition in between there, and now I'm going to add negative 14y minus 35. So as my first step, I put this into two groups of two. And so this 6xy plus 15x minus 14y minus 35 is now equal to, grouped in parentheses, this expression 6xy plus 15x, and then I'm adding a second expression grouped in parentheses, which is negative 14y minus 35. Now that I have my two groups of two, I'm going to look for the greatest common factor of each group and then see if there's a factor common among my two groups. So with 6xy plus 15x, the most that I can factor out of there is going to be 3x. So between 6 and 15, 3 is the greatest common factor, and between xy and x is the greatest common factor. So I'm going to factor a 3x out of that first group, and when I do that, I'll be left with 2y when I factor 3x out of 6xy, and then when I factor 3x out of 15x, I'll be left with plus 5. So that first group factors into 3x times that expression, 2y plus 5. Moving on to my second group, again I'm using addition. In order for me to see if this has a common factor, I really want what remains to have a leading coefficient that's positive. So if there's a negative leading coefficient, which I have here, negative 14y, I'm going to factor out the negative part. So looking at negative 14y and negative 35, the most that I can factor out there is a negative 7. So I'm going to factor out that negative 7. And then I'll be left with 2y when I factor negative 7 out of negative 14y. And when I factor negative 7 out of negative 35, I'm left with a positive 5. So for that second group, I have negative 7 times the expression 2y plus 5. Now at this point, 2y plus 5 is a common factor of each of those groupings. So now I can factor out that 2y plus 5. And when I do that, I'm going to be left with 3x plus a negative 7, which of course I can simplify to 3x minus 7. So when fully factored, I'm going to have 2y plus 5 times the expression 3x minus 7.